Hi, in this tutorial, we will create a magnetic starter with thermal overload protection, which is start-stop, basic start-stop operation of a motor or a three-phase motor. In creating a circuit diagram, go to the drawing toolbar, look for your power feedings uh, for three-phase power supply. So in this tutorial, I will use this three-phase supply, and we will zoom, no? Adjust our viewing uh, for our workspace. So in this line, we will rotate it in a right way position. Yeah, definitely good. No? Next thing is we will create a line, but in the line I preferred a color one, so I use three-phase supply. So three-phase supply. Okay, change the color. I want the color red one. So red one, and I will adjust also the width size. And next thing is the blue one. Okay, so change the blue one, and okay, I just move it here. No, and I will use the red one, the yellow one. And for the grounding, I will use the ground wire or the PE. After you after you create power feedings, next is we will use a disconnect switch, disconnect fuse, or could be circuit breaker. But for this tutorial, create an automatic switch, a three-phase automatic switch. Okay, three-phase automatic switch. Next is um, the magnetic contactor. So three-phase magnetic contactor, and at the same time, we look for overload, overload relay here. Also use overload relay, and of course, three-phase motor. Three-phase motor. That, that's it. And we will edit this component. To edit this component, just double click and replace its name. I will replace it to QF1, QF1. Okay. Then I will replace it to KM1 since I will use IEC standard magnetic contactor 1, and we'll label this as F1. Okay. So delete the other one. Okay. And we'll replace its name to M1. Okay. You can also choose either 2D image, or you can also choose the 2D Y image, or depends on your preference, no? But you can also use 3D one, but I prefer to use a symbol, just a symbol for motor. So we will connect this circuit, the same line or the same connecting wires. I use a colored one. Prepare the color one. Change its width. Okay. Then make sure all the connections are properly connected. And then I choose the blue one, colors, two colors. Okay. Choose the blue one and the yellow one. And I will create also this one for the block, assuming it's directly connected each other. Oh, I have mistake here. To delete the component or the lines or the wires, you need to click click the wires and delete. For this one, you can also delete this one. We will use red one. Color one, yellow. I think it's a yellow one. Okay. And for the ground, make sure the ground is connected each other. And same thing is we will label this one as source. And we create a text. Text is this is the power circuit. No, cancel. We need to cancel. We need to I prefer to use the color for the text is the black one. So power circuit diagram. Power circuit diagram, and we replace the font size 12 bold. It's okay. Okay, press OK. Okay. And power circuit move. We will move this to upper side. And then for the level, I use the black one. So this is a 460 volts BAC 3-phase. We'll reduce the font size to I think 9. And same thing, I would like to use a bold one. So this is a 460 B volt supply, power supply. And then I will label this as motor feeder. Motor feeder. It's what we call the motor feeder lines. And this is what we call the uh, disconnecting or branch circuit protection. Branch circuit protection. This is what we call the branch circuit protection. This is what we call the motor controller. Label this as a motor controller. This is thermal overload protection. Thermal overload protection. Okay. And this is what we call the motor. This is what we call the motor. Motor. This is called 3-phase. Labeled as 3-phase. You can also check this one to indicate it's a 2-phase motor. Then for the control circuit diagram, so we'll use a single phase one for the motor circuit diagram. So go to power feedings, we will use since it is 460 volts. For the controller, you can also use the transformers. You can also use step down transformer for the control transformer, but I will use also here the disconnecting fuse. Disconnecting fuse. Okay, it's called the disconnecting fuse. Okay, and of course, I will use a circuit breaker for its isolation for the load side. Okay, so we'll connect it based on its no, connection. I will use the line 3 and the line 2. Line 3 and line 2, I prefer the color one, which is the blue one. So line 3. And of course, let me just connect this. Okay. And I will also, I prefer line 3 and line 1 rather for the red one. Right one, red, connect this. Okay. 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 For this one, I prefer to use this output connection and the input connection for so that our connection will not become messy. So I use the output connection 1, 2, and we will rotate it to, okay, let me just rotate it. Okay, that's good. Okay, next rotate this. Okay, we will label this as, since we already have a F1, we'll use F2. And this is we label is as T1. Of course, we will label this as not X, it is L1 or the line 1, and this one is will become the line 2. And we will copy this, Control C and Control for the control circuit diagram. Control circuit diagram. Okay, okay, okay. For the control circuit diagram, so since we already used the output connection, we will use an input connection. So input connection, okay, let me just, okay, and we will rotate it to turn right. Use turn right and become this one. Okay, we will label this as L1, line 1, and we will label this one as line 2. So this is the supply. This is the connection between here and the control circuit diagram. So since we already used the thermal overload, we will go to the here. Where is it? This one. The uh, thermal overload, the normally closed one. This is what we call the thermal overload, 95 and 96. The normally closed, and we will use a push button, which is uh, normally open, and we will use also a normally closed one for the push button, stop push button, and let me just move. Okay, stop button and normally open auxiliary contact. Normally open auxiliary contact. Okay. To edit the component, you should double click once, label this as S1 or PB1. You can also, for this stop, this is what we call the stop push button. Stop. Okay. This is what we call the S2 or PB2. Then start. Okay. Check this one. Start push button. This is what we call refer to KM1 since it's normally open of the magnetic contactor. We will use a KM1 and 1314. Okay. To edit this connection, you can also replace this as, say, for example, 3, 4. You can also edit this one, 3, 4. And we'll replace this as 1 or 2. Or you can also use as it is, no? And okay, KM1. Okay, this is what we call the KM. And of course, we will use a holding the coil of the magnetic contactor. Go to the coils and signals. Use this one, the coil. Okay, okay. So we will label this, of course, magnetic contactor 1. Function niya is holding coil. It's a holding coil. Okay, M1 coil. And we will connect this connection. No? We connect this connection. I prefer the red one since the connection of line 1 is normally closed. So we label this as normally close, and we will label here. And for this one, I prepare the blue one for your easy to understand it how the circuit connects. Okay, for this one, I will use the black one. Depends on your preferences. You can also change the colors. For this one, since it is overload referring to F1, we will label this as F1. Okay, and we will label this as OL. This is overload. Overload, thermal overload. This is the start push button. This is the start push button. This is the holding code. And we will label this as QF2. Okay, QF2. And next thing is we can also simulate this, but I prefer for the simulation to use a push button. I prepare a push button here to, okay, push button 1 and 2. To edit this component to replace this color, and also we'll refer this as S2 for the green. You can also change its color to green. Okay. And we will replace this as S1 but in red. Okay. And of course, I prefer to use like this now. I would like to use a rectangle. Okay. So we will label this as start. Start. Okay. Start. Okay. This is called the stop. Stop push button. And we will place it back here. Okay. So to uh, simulate the connection, just um, press this one, the simulation, to activate this one. So you will notice that the circuit is already been simulated. So the connection is already in simulation scenario. Will notice around here in the below side, no, lower side, lower portion. Let me just grab a rectangle. So we'll notice here, it is already in run function. To activate, no, to energize circuit, we need to activate this fuse or this circuit protection. Activate this one, For the branch circuit protection, this is what we call the control circuit protection activate also. So we'll notice that the transformer is already energized. Next, we will activate this circuit breaker. Then you will notice that the power is already been energized for the thermal overload and this stop one. So there is a presence. So to simulate to run this motor, we'll press the green button, or you can also press here the same scenario, uh, stop one, or you will press here in our push button. So press the start button. So the motor should start. When normally open contacts of the push button close, the sup- there is already a supply of 220 or 230 volts motor starter coil. As a result, the starter contacts also close, allowing the three-phase power to flow the motor. So the seal-in circuit ensure that the circuit remains intact even after releasing the push button. When we press the uh, stop push button, it will break the seal-in circuit, resulting the motor turning off. So let's simulate again. Okay, then press stop. That is how a simple start-stop operation, a simple start operation of the circuit operates. And that's it. If you have a comment or suggestion, feel free to ask. No? You can also comment down below for the if you have a questions. No? Next video, we will create a start stop with indicator lights for the next video. So thank you and have a great day.